Hello, my name is Dr. Thayer Morrill. I'm in the Department of Economics here at NC State. We'd like to thank you for participating in this experiment. So before we get started, we want to go over a couple of things about the overall setup of the experiment and then go through some specific examples to make sure that everything is clear. So first, you may see some other people in the room, but note that none of these people are involved in the same experiment that you are. All the other subjects in the experiment will be played by a computer. The computer, we're choosing schools, and the preferences of the computer subjects will be chosen or just determined randomly. So in each experiment, you're going to be giving a ranking of schools and a certain number of points assigned to each schools. And your sole objective is just to try to get into the school that has the highest number of points possible. You're going to be paid more if you get into a school with more points, and so the better school you can get into, the more money you'll get paid. So the preferences, the computer, like you, will have random preferences, but those will just be determined randomly. So in the different experiments, sometimes there'll be 4 schools, sometimes there'll be 8 schools. It'll just depend on the different experiment, but all of this you'll be able to see. You'll be able to see the number of schools that there are, preferences, the total number of seats available, and you'll also be able to see the number of the computer subjects that have ranked each school first. So for example, if there's school A, you'll be able to see how many of the computer subjects rank school A first. Okay, we're going to go over 2 things that determine the assignment. The first is the priority, about what each student's priority is at school, and then the second is how these priorities are used to determine the assignment. So there's 3 things that matter for the priority of the school. First is each school has a neighborhood student, and the neighborhood student always has the highest priority. So in this particular example, the neighborhood student of A is 1, the neighborhood student of B is 2, the neighborhood student of C is 3, the neighborhood student of D is 4. And so the neighborhood student always has the highest priority. Second, we look at who ranks the school the highest, and then finally, if 2 students rank the school the same, we'll use a random tiebreaker to determine who's higher. So here we have a random tiebreaker, and so the numbers are set up, and so 1 is random tiebreaker is 0.5, 2 is random tiebreaker is 0.7, so if 1 and 2 rank a school the same, 2 will end up with a higher priority. Okay? And then each round. Okay? So we'll go through each school. So A, so we always look at who is the neighborhood student first. So A's neighborhood student is 1. Okay? So now, the remaining students 2, 3, and 4, we look of these students, which one ranks A the highest. So 2 ranks A first, 3 and 4 rank A lower, so 2 has the second highest priority at A. Now we look at 3 and 4, and so in this particular case it happens that 3 and 4 have ranked A the same, which is both of them has ranked A third. So now we have to look at the tiebreaker, and 4's tiebreaker is higher than 3's. So 4 is ranked next, and finally 3. So let's do the same thing for B. So first is always the neighborhood student. So B's neighborhood student is 2. Now we're looking at between 1, 3, and 4, and we're asking who ranks B the highest. 3 and 4 both rank B first. 4 has the higher tiebreaker. So 4 is ranked next, then 3, and finally 1 is ranked last. Okay? C, we look at the neighborhood student. In this case, that's 3. So now between 1, 2, and 4, we ask who ranks C the highest. 1 ranks C second, 3 ranks C last, 4 ranks 3 second. So it's between 1 and 4. 1's tiebreaker is higher than 4's. So 1's ranked next, then 4, and finally 3 is ranked last. 2 is ranked last. Okay? Finally, we look at school D. So again, the neighborhood student is always first. D's neighborhood student is 4. So we're looking between 1, 2, and 3 and asking who ranked D the highest. In this case, 3 ranks D second. 1 and 2 rank D third. So the student that ranks D the highest is number 3. 1 and 2 rank D the same, so we look at the tiebreaker, and 2 is a higher tiebreaker. So 2 is ranked next, and finally 1. So now we've changed the example. We're going to show you how the preferences and the priorities are used to determine the assignment. And it's going to happen in a very natural way. Okay, so the computer, once the computer knows the preferences of the students and the priorities of the schools, it's going to handle this application process internally. And so what happens is that each student is going to apply to their favorite school, and the school is going to hold on to the student with the highest priority. Any student that's rejected is going to apply to the next favorite school, and so on. So we'll work through this example. Okay? So each student applies to their favorite school. So in the beginning, 1 and 2's favorite school is A. So 1 and 2 apply to A. 3's favorite school is B, 4's favorite school is B. So that means B, 3, and 4 apply to B. So 1 has 2 applications, 1 and 2. 1 has the higher priority, so A is going to reject 2. And so this means that 2 is not going to be assigned to A. And so it's just going to hold on to his favorite application, in this case, student 1. B, 3, so 4 has higher priority than 3 at B, and so this means 3 is going to be rejected, and B is going to hold on to 4. So next, 2 has been rejected, and so we know it's not going to go to A, and 3 has been rejected, we know it's not going to go to B. So 2 is going to apply to school C, and 3 is going to apply to school A. 4 is still applying to B. Right? So the only school with the decision to make is A. So here it's choosing between 1 and 3. And so 1 has higher priority than 3, so it's going to reject 3. B continues to hold on to 4, C continues to hold on to 2. So 3 was rejected again, so now 3 applies to C, which is his next favorite school. So now, just to make this clear, A is holding on to 1, B is holding on to 4, and C has 2, which is holding on to, and now 3 is applying to it as well. So C looks at this and sees that, okay, 3 has higher priority than 2, so it's going to reject 2. So notice that C held on to 2 in this round, but it's still the case if you could hold on in one round and be rejected in a later round. And that's if the student with higher priority applies. Okay? So 2 is rejected by C, and so now 2 is going to apply to D. So in this round, A is still holding on to 1, B is still holding on to 4, C is holding on to 3, and 2 applies to D. And so now notice that there's no rejections in this round. There's exactly one student applying to each school, and this is when the process stops. So the school holds on to your application and continues to hold on to it unless a student with higher priority applies to it, in which case it will then be rejected and you apply to the next highest priority. And all this application and rejection is done by the computer. It's all automatic.